Hello. So before we start with the presentation, I would like to comment, for reasons, I happen to have 2 copies of this excellent book by Vladimir Demantiev. It's a book about how possible ways to evolve Rails applications when they grow. It will make you think. So I bought my own, but then I got a second copy from the publisher for reasons. Anyway, so this is not a promotion in any way, but since I have 2 copies, if there's any junior developer or anyone that just started working on Rails, I would gladly give the book to this person. So if there's anyone that just started doing Rails and wants this book, please reach me out later and I will give it to you, right? Okay. So let's go. We are going to talk about Zeitwerk. So maybe you know Zeitwerk is this library that allows you to auto-load, reload, and eager load Ruby code. Is the one that is currently doing these things in Ruby on Rails, but it's also, it can be used by any Ruby gem, any Ruby project, as long as it complies with the naming conventions, okay? And maybe you do not even realize that your dependencies may be using Zeitwerk. There are like 500 gems plus using Zeitwerk currently, in addition to Rails, right? So you may not realize because one of the design goals for this library was transparency. Transparency meaning that your project should look like an ordinary Ruby project, except for the lack of required calls. It should just look normal, and I wanted an interface that is nowhere. There's nothing about Zeitwerk in your code. You do not have to write anything special in your classes. You know, you have a regular Ruby project, and Zeitwerk somehow, you know, hooks into the project externally. You don't see it, all right? So even if you are working in a Rails application that is not using Zeitwerk, like a Rails 5 application, Rails 6 in classic mode, maybe some of your dependencies are using Zeitwerk, but you do not know this. However, this is the interface that I like it to provide, but that doesn't mean that Zeitwerk has to be magic, all right? I don't like this word. I believe it's better if you use your tools knowing what they are doing, okay? So I understand this kind of interface as a catalyst. Like, I could write this by hand. It could be, you know, a little bit verbose and fragile, but I could write this by hand. I have a tool that automates this for me. That's the idea. And it could be nice to understand what is the tool doing for you, right? So now you can use it, but you know what is happening. So this is the talk about. It's about explaining how Zeitwerk does this work. But before going into that, Zeitwerk is all about constants in Ruby, okay? So constants in Ruby is a big topic, and at least we need to be on the same page regarding a few specifics of constants in Ruby in order to be able to follow the implementation that we are going to see later, right? So let's dive into that. First thing, and this is very unique in Ruby, the class and module keywords store classes and modules in constants, class and module objects in constants. What does that mean? So we have here class C, all right? And then below, a class new call that gives you a class object, because in Ruby, classes are objects, modules are objects too. And we are storing that in a C constant, all right? The one at the bottoms is like a regular assignment. So the point, and this as Ruby programmers, is very important that we understand this. Both things are doing the same thing, okay? So that class C, that C is not a type. That C is a constant. So Ruby, behind the scenes, is doing the same thing that we have at the bottom. Same with modules, okay? When you say module M, Ruby, behind the scenes, is instantiating a new module object and storing that object in the M constant. It's the same thing. All right. The next one is that Ruby does not have syntax for types. And this is very important because it's not that intuitive, especially if you come from other programming languages. Does not have syntax for types. Let's understand what this is. Okay. Let's for a moment stop at this slide. We are storing a 0 integer in the X constant. And then we ask, are you even? Yes, I am. All right. So in this slide, I guess all of us understand this slide. It's not surprising. All right. We store 0. Of course, 0 is even. Good. What is happening in the second line? So X is a constant, right? Which is the value that you are storing? 0. 0 responds to the even predicate. And the result of that predicate is true. All right? Nothing surprising here. But if we go through the details, that is what's happening. All right. So the next slide is very important. Okay? When you write this, it's the same thing. Exactly the same thing. So that project .find is not, we are not, so project is not a type. Project is a constant. It's just storing a value. The same thing that we had before. This is X storing a value, right? Yeah, so here, project is a constant that is storing a value. Which value? A class object. A class object, that class object responds to find. Okay? So this is very, very important. We are not seeing, this is not a type. It's a constant. It's a regular constant. All right. Next thing. Constants belong to classes and modules in Ruby, okay? And top-level constants belong to object. Again, this is something very unique about the Ruby programming language. Because in other programming languages, constants are just a trivial topic, right? And they are kind of variables. But in Ruby, they are more than variables, quote unquote. They belong to the object model of Ruby. So they explicitly are entities that belong to class and module objects. And that's why we have an API to manipulate and to ask about this collection for every class and module object. This API is precisely accessing this collection, which is explicit. This belongs to the Ruby model. So we can ask, for a given constant, we can set the value of a given constant in a given module or class. So all the constants that you see in your source code belong to some particular class or module object. For instance, if we say we define a class C and we ask object, which are your constants, no C is going to be included because, as we saw before, that's a constant assignment. You see in this collection that C is included, and you just see ellipses here. What are those ellipses? Well, all constants that are top level belong to object. So we are going to link a few ideas now. When you write a string, or you write hash, or array, or math, or kernel, or object itself with capital first letter, that is not a type. A string, capital S, is a constant, regular constant. There's nothing special about that. It stores a class object that was created by the interpreter when it launches, right? But it's not special. So if we listed the whole collection that is returned here, C is going to be included, but all of these other built-in classes and modules whose constants are stored in object would be also listed. Now, I want us to see the same thing using the API. Okay? So we have class C there, and there's a class object stored in the C constant, which is what we saw in the previous slide. And now we are going to see a third way to do the same thing, which is instead of doing a constant assignment with this syntax, we are going to do a constant assignment using the API, which is the third chunk. All right? So in the third chunk, we say object, please store the constant whose name is C, and assign to that constant the class object that we are creating in the second argument, right? This is the same thing. Why object? Again, because top-level constants belong to object. So we see here it really belongs to that class in this sense, in this case. All right. Now let's introduce nesting. Okay. We have a module M, and nested we have class C. This is the way Ruby kind of emulates the concept of a namespace. All right. Ruby properly does not have namespaces like other languages do. But this is like the emulation that allows us to separate things in practice. Okay, so if we list the constants in object, the top level ones, M is there, right? Together with a string and the rest. But the nesting allows us to create a C constant in the module object we are nested in. So that's why we can now ask M for its constants, and C is included, and there's nothing else. All right? That C nested is a constant. Where is this constant stored? In the module that is stored in the M constant. Okay. Now, with the API, same thing. We are going to do the same thing using the API. I am showing the API because we are going to see the API used later by Zeitwerk. All right? So, in object, we assign an M constant, okay, with a module inside. Now, after this first line, we can refer to the M constant. How is that possible? We didn't say module M with a keyword. Precisely, because the module keyword is only doing a constant assignment. The moment you have a constant in object, you can refer to that in the source code. So that works, okay? We can say now M concept, you know, and then in M we are storing C, the same thing. This is the nesting, all right? And we can list the constants. We would see the same thing. Finally, module autoload. This is an API that is not used a lot. It's used, but not a lot. Allows you to load constants on demand. Okay. This concept of autoloading constants comes from the fact that constants are like you see, a big topic in Ruby. So they are stored and we can autoload them. There's API to do that. For instance, this is background. Background uses autoload. Okay. So this is the API. Okay. Background defines a namespace background and says autoload action string. What does that mean? That means that background does not need to require background / action everywhere background : action is used. It doesn't need to do that. Why? Because by setting this line instructs the Ruby virtual machine to load with kernel require the string that is in the second argument whenever you hit background : action for the first time. Okay? So the first time you hit action, Ruby stops for a moment and says, well, I don't have action, but I have an autoload for action. Go, fetch the file, load the file, and if everything is as expected, action is going to be defined inside the background module, continue execution. Okay? That is handled by Ruby. And this is the key API Zeitwerk is based on, module autoload. Because Zeitwerk, it's an autoloader in the sense that it gives you facilities to autoload your project. However, Zeitwerk itself is not the one doing the heavy work. heavy work is doing by Ruby because Zeitwerk is using this API, okay? And that is also one of the design goals of Zeitwerk, to use as much of built-in Ruby as possible, right? Now, again, let's see that using the API. So in the previous slide, we have an autoload there. Okay, what is that? That is a method. A method invoked on which object? Well, there's no explicit receiver, so that is self. Who is self in the body of a module? The module itself. Okay, so we are invoking the autoload method in the background module. That means that this thing is doing the same thing. Okay, in the background module, we are calling the autoload method with those arguments. Okay? Okay, we are ready. We have the basics to follow. All right, so those are the main ideas in which Zeitwerk is based on. Now, we are going to see source code, but it's heavily edited because there's a lot of things that it could take too much time, all right? However, we are going to see what I believe is the essential ideas behind Zeitwerk. So after this talk, we know how it works. Then after that, this last mile, okay? We ignore files, we are able to collapse the directories. There's a whole bunch of features that we are not going to see because they are kind of secondary to the goal of the talk, okay? We are going to see how it works really. Okay, so maybe, I don't know if you have ever used Xavier by hand, but this is the raw API. It's still very simple, okay? But in Rails, you do not even need to do that because Rails does that for you. But this is the raw API. The raw API is give me a loader, and then I say, this is my root directories, what we call autoload paths in Rails, and call setup, and that's it. You don't have to do anything else, all right? This can be done in any Ruby project. Doesn't have to be Rails or hasn't to be a gem, doesn't matter. As long as below those directories you follow the naming conventions, it's all you need. It's going to work. Those directories, I wrote APP controllers and models so that they sound familiar, all right? But we are not in the context of a Rails application. This is just examples, all right? Those represent the top-level namespace. They represent object, okay? What does that mean? So if we have app/models/user.rb, that means that file is expected to define the top-level user constant. Okay, so anything below models or anything below immediately below models or controllers is expected to define the corresponding top-level constants. Okay, okay. Now, let's base this walkthrough on one particular example. Okay, so let's imagine that we have users controller, a namespace admin, okay, that has a roles controller. And then we have also a user model and admin/role RB, okay? Let's imagine we have these files, okay? Given this project structure, what is Zeitwerk going to do for us when we invoke the setup method, okay? So we push the directories, we call setup, and everything is ready. Why? So what Zeitwerk is going to do is the following. It's going to define autoloads dynamically for us. So in object, because we are in the top level, in object, we are going to define an autoload for users controller, an autoload for user, because those are the top level, they are not namespaced, okay? So an autoload for users controller, an autoload for user, and an autoload for admin. What is going to be required? The corresponding file, okay? So we are going to define an autoload for users controller that requires users controller what is when it's needed. Same for user, and admin there's a curiosity here because we are going to have a require on a directory, which is something a little bit weird, but we are going to understand. So these are the autoloads that setup is going to define on our behalf, all right? One bit that is worth mentioning is that Zeitwerk always works with absolute paths. So you see there's an absolute path there, right? The reason is we know exactly which is the file, and we have the absolute path for that file when Zeitwerk works the project tree, as we are going to see. So require is not going to do, so if you pass a relative name, a relative path to require, there's this concept in Ruby, call it the low path. And conceptually, at least, Ruby needs to say, let's imagine we say require Nokogiri, all right? So there's a bunch of directories, call it the low path, and Ruby has to go one by one, conceptually at least, and say, this directory, do you have nokogiri.rb here? No. All right, next directory. Do you have nokogiri here? No. You know? So by using an absolute path, this lookup doesn't happen. Ruby goes straight to the file, there's no lookup happening, and the file is loaded, which is more performant. All right, how do we do this? Well, we have two root directories. In Zeitwerk, they are called root directories, okay? So this is the implementation, simplified implementation of setup, okay? We are going to iterate through the root directories. In this case, is app controllers, app models. We have two of them, okay? For each one of them, we are going to define autoloads, okay? So we have this card. We iterate, we do this thing for these directories. Let's see what this define autoloads for these does. Very simple, actually, okay? So we got the dir. We got also namespace because, as we are going to see, this is used when you visit things deeper in the project. And indeed, the root directories can also represent other namespaces besides the top-level namespace, but doesn't matter. In our case, we can imagine that namespace is object because we are visiting the root directories and they represent objects. So dir is going to be app controllers object in one call, and then the next call is going to be app models object. That's the namespace associated to that directory we're visiting. All right, we're going to list the directory, and we have this ls utility that basically just yields Ruby files and directories. Anything else is ignored, okay? And there's more stuff. There can be hidden files. There can be JavaScript files. There can be, I don't know. And so this is a utility that Zeitwerk uses internally that you can be confident that anything yielded here is interesting for the purposes of autoloading. And there's two things that can be yielded here, a Ruby file or a directory. Okay? Directories represent namespaces. Ruby files represent things that define constants. Okay? So now we branch. If we get a file, we're going to do something. If we get a directory, we are going to do something else. In the case of a file, the idea is simple, actually. Okay? The idea is simple. We got the loaders have an inflector that given a file name in a snake case is going to give you the expected constant name in camel case. Okay? So from user.rb, we are going to get user capital U. From users controller.rb, we are going to get users controller in camel case. Okay? That the inflector gives you this transformation from the file system to the constant name. So that's the first line, the C name, the constant name, which is the name that we expect this file to define. We have it there. Now, you see the autoload call, which is the same thing that we saw in background. Here, we are saying namespace. Now it's object. It could be something else deeper, but now is object. Object, let's simplify. Object, autoload, CNAME with this absolute path. All right, so we are using the API that we saw before. For instance, it could be object, autoload, symbol user, capital U, with the absolute path to app models user.rb. This is the call, this is the key call, okay? Because we are setting an autoload for the user class here. And then we have some housekeeping. We remember that this absolute path was set to this pair of namespace and CNAME. And then there's a global registry that also remembers some metadata about that we are going to see later, the use of it. Okay, but it's actually simple. We camelize the name, we set an autoload, and do some housekeeping. That's the key idea. Then if you look at the source code, there's more things, but they are more secondary. This is the key idea. All right, so we have the autoload set. Now, in the case of a directory, it's a little bit different because that represents a namespace, all right? So same thing, we camelize the name. So from admin, we get admin capital A. And then we compute the constant path that constant name represents at that point in the project. Since we are at the top level, the constant path is still going to be admin capital A. Now, the thing is, we do not need to go through all the details, but the thing is, as you know, a namespace can be spread over multiple directories. We can have admin, as in the example, actually, in controllers, we can have admin in everywhere, okay? So a namespace can be spread over the project, all right? So basically, we need to remember that the admin namespace is defined in these 5 places, okay? In the example, in 2 places, right? Okay, we have the autoload call as we had for the file, and the autoload call apps path there is going to be directory, right? Okay, so this is what summary of what we did. Okay, summary. The loader has scanned the root directories. Okay, it has scanned the project. Only one level. This is important because Zeitwerk is as lazy as possible. Okay, even if you have multiple levels down, doesn't matter. It's going to do only one level. Only one level. Now, we have defined autoloads for the things that we have found in that first level of project scan. But it's important. These autoloads are declared, they are defined, but they have not been triggered. We have only made the autoload calls. Okay, and we have some internal state. Now, the setup call returns, and the loader stops and waits. All right, so summary, we have scanned one level, we have inflected the file names, define autoloads for them, stop. That's all the loader does. When are things loaded then? Well, when they are used, that's the point. So autoloads, the autoloads that we define are triggered by using the constants. If you do not use the constant, the file is not going to be visited. It's not going to be loaded. Okay? If you use the constant, then Ruby itself is the one that is going to require the target file. And Zeitwerk has a decoration of kernel require, because require is what is going to be called. Okay, we have a thin, very thin decoration of kernel require, because when things are loaded, we need to do some housekeeping. So we need to intercept those things, okay? There are a few gems that decorate require. For instance, Bootsnap does it. Ruby gems also does it, okay? So gems that are like very concerned about loading things, It's natural that they have to decorate a little bit kernel require. But in the case of Zeitwerk, it's super, super thin. Okay? And this is where the registry enters into play. Because if there's a require, and we have, the registry says, do you have a loader for this path? Okay? If there is a loader, we are going to do some things. If there is no loader, this is not managed by Zeitwerk. So call the original require, and that's it. All right? So if we get the full path to user.rb, we are going to find a loader. But if we get require no cogiri, it's going to go to the else clause. Okay? All right. Now, why there's a registry and this question? Because there can be multiple loaders in the same process managing different source trees. So a Rails application has two loaders, main and ones. And then perhaps you have three other dependencies that are using also Zeitwerk, and they are loading using Zeitwerk. But then we would have maybe 5 loaders, you know? So that is what the registry is doing, is keeping track of which files are we managing and which loader is responsible for each one of the files. Okay? There's a natural requirement that is that different loaders should not overlap. Okay? The projects of different loaders have to have no intersection. All right? Okay, so let's imagine that we got a loader. There's only 2 possibilities. Either we got a file, or either we are loading a directory. Okay? And since we intercept this call, we can deal with directories, which is something that Ruby does not do. There's no sense in issuing a require for a directory in Ruby. But we intercept this call, so it's up to us. Let's see what these things do. All right, so basically, if we get a file, we are going to call some internal callback on file autoloaded. Okay, when a file is autoloaded, we just keep track of things and we validate that the file defines what we expect to define. And if reloading is enabled, which is not by default, if it's enabled, then we keep track, okay, we autoloaded this thing, because then if we reload, we need to unload this thing. Now, if a directory is required, there's a different callback that basically does more or less the same thing, but the interesting line here is that the third one in the body of the method, because we are defining a constant with const that defines a module. There's module new there, right? So as you know, in the admin namespace, we do not need to write admin.rb. If there is no admin.rb, the loader on the fly defines a module for you. This is the spot where this happens. We instantiate a module object and we say, okay, in this constant, for this namespace, cref1, cref0, we define on the fly the module right there. This is the way it's done, okay? All right. Now, when a namespace is loaded, which is what happens when a directory is loaded, then we go to the list of directories that define that namespace and scan one level more on demand. This is what this code is doing. We are calling here the method that we saw at the beginning. Okay? This is what closes the loop. Okay? We set autoloads, wait, don't do anything. When things are loaded, if they are loaded, then you respond. And in the case of directories, this is where you go and set autoloads for one level more, below that namespace that was just defined. Okay? So, at this point, in the admin module that we just defined it on the fly, there's going to be an autoload for the roles controller and an autoload for role. That's the idea. We define autoloads, we hook into kernel require to close the loop. Right? Now, there's an interesting technical detail about explicit namespaces, which is when admin.rb is defined. But we are running out of time, so I'm going to skip this section. It's not that essential. It's just a technical detail. So this is the summary, okay? We scan the root directories, one level, define autoloads for their entries, then wait, don't do nothing. When they are triggered, if they are triggered, then requires are intercepted. Dummy modules are created on the fly, and in that moment, we descend one level more for that particular module. So if you have, I don't know, 100 namespaces, but you only use one namespace in one particular request, we are going to descend only one level on that namespace. The rest of 99 directories have not been visited, okay? So Zeitwerk tries to be as lazy as possible all the time. Okay, very quickly, how do we reload? This is going to be only, summarize it, all right? But now we have the key ideas. To reload, if we have reloading enabled, we remembered which things have been autoloaded, all right? So we have that collection. We just build it on the hook, okay? So there might be autoload set that have not been triggered, okay? Let's remove those autoloads. For the ones that were triggered, we remove the constants. How? With the constants API. Again, you can remove constants from class and module objects. We remove the constant, okay? There's no way in Ruby to reload code, actual code, okay? Like VM instructions. So when we say reload, is an abuse of language. What we do is we remove the constant. If everything is as it should be, the object that was stored in that constant is not referenced anywhere else. So it's subject to garbage collection and eventually it's going to be unloaded. That's the whole story, all right? Okay. Now, we need to delete the autoload files from loaded features. Loaded features is a collection that Ruby checks for doing requires, okay? You know that require is idempotent. How does that work? So Ruby checks this collection and says, I don't have this file in this collection, go and load it. But if I have it in the collection, it's going to return false and do anything and do nothing. Now, when we are going to reload, we are going to run a setup again, which is going to put autoloads again. Those autoloads, if we do not manipulate loaded features, wouldn't load anything, because at least for the things that were previously loaded. Why? Because there was a require executed, okay? So even if we define again an autoload, if the file was required before, Ruby is going to pass. So this third item is the way we make Ruby believe that the file was not loaded, so the autoloads actually get triggered and load the new files in general as they are defined. And finally, eager load, which is an aspect of the implementation that I like a lot, because for eager loading, Zeitwerk uses itself, and I believe this is beautiful. Eager loading is a breadth first project traversal, okay? So we first go one directory, and then we go one level at a time. And the point is, we do autoloads. So Zeitwerk, the eager loading in Zeitwerk is not a recursive require, which is the natural implementation, and indeed the first implementation was a recursive require. But that has a number of issues, edge cases, that made me think, wow, why not autoload? So we have the metadata to autoload. So just autoload, right? So that's what it does. It makes a project traversal, breadth first, and takes the metadata and says, okay, autoload this constant. If the constant was already loaded, fine. It's going for namespaces, fine, okay? It's going to issue just one require. So recursive cons get, that's it. And that's it. All right, go ahead. Thank you.
One question. Any question?
Hi, thanks. That was a great talk. I have a couple of questions. One is about the ls method, the utility method, which lists the Ruby and directories, Ruby files and directories. How do you identify Ruby files? Is it by extension?
Yeah, by extension.
Okay. Another question I have is about the recursive, not recursive loading. Does that mean that it's not a drop-in replacement for other autoloaders, which recursively load, which means that potentially the order of loading different files might be different than in other loaders?
I didn't understand the question.
I mean, like, if you recursively load, that would be potentially different order of loading different files than loading the Zeitwerk way. All
right. So when you eager load, yes. So when you auto load, that's lazy, and it's going to load things on demand.
Yeah, I mean, in case of eager loading.
Yeah. So it's true. So auto loading is going to load things in the order in which they are used, and eager loading is going to auto load everything. All right. It's true, but it's consistent. That's the point. It's consistent. And even for different file systems, eager loading, when it lists, so the listing is always ordered. So the order in which things are eager loaded is consistent across CI, across the project, production, everything.
And it's ordered by alphabetically, I guess.
Alphabetically, yes, exactly.
Thank you.
Yeah.
Okay.
Should.
The short one, please.
Short one. Yeah. Is there any plan to make it part of core Ruby at some point, autoloading, or somehow those concepts, right, to make it easier for everyone except for Rails community or using gems, like at the more core level?
So that's a good question, and I have been asked this question a few times. I don't know, in the sense that I am not in Ruby core. I don't know which is the sensibility there, but I have to say that Zeitwerk does not go along with the design of Ruby, I could say. It's a little bit of an outlier in the sense that Ruby, the philosophy of Ruby is that there's no relationship between file names and anything that they can define, because we are used to define class and module objects there. But when you require a Ruby file, what happens there is arbitrary, right? So there's no relationship between anything. It's super flexible. It's it's files and requires. So it goes I would say, against this philosophy that I do not even know if it makes sense for Ruby core to integrate this. But that's my answer. Yeah. Yeah.
Okay, thank you very much, Xavier.
Right.